Today, we're getting into how hardware and software teams think, operate, and build differently, especially when they have to deliver together. So I'll start by asking you, is it important for a defense company to do both hardware and software, or do you think pure play hardware or pure play software companies can be successful in this environment?
I think the most important thing for defense is you have to build complete systems. The government doesn't know how to ingest like components of systems. And so a mistake we made when we started Vannevar was we built, Arabic optical character recognition, like a API service that basically you feed it an image, it outputs the text that's in that image and translates it. That's like a feature of a feature in DoD land. That's like such a small slice of the pie. And so the thing that's most important when building in defense is, are you building an end-to-end system that solves a top 3 mission problem? You can do that with software. You can do that with hardware and software. And I guess you can do that just with hardware. I think there's like different combinations of that can work. But as you scale, I think like as you go after bigger and bigger mission problems, and as you kind of build more and more complex things, you do eventually, like at least for us, we ran into having to build a combination of both hardware and software to solve the types of problems that you want to solve. I don't think there's anything definitionally that like that requires that for certain companies. I think Palantir is like a great counterexample of like they have spent a long time building just hardware for the government, and they've done very well. But I do think like as your ambition increases, like the complexity of what you're trying to tackle increases in defense, that can lend you to more of like having to be excellent at both hardware and software, which is hard to do. It's like very hard to do.
Recognize that Vannevar is still pretty early in our hardware journey.
Yeah.
Can you go into what that decision was like to get into hardware at Vannevar?
Yeah, for sure. Yeah, and just to be clear, like I'm speaking like I'm an expert on hardware. I'm not. We're very, very early days. But for us, it wasn't a decision to get into hardware. I don't think about it as like we're only building software, we're only building hardware. Like I think about it more as like, what are the mission problems we're trying to solve, and like what does it take to solve that mission problem? And so the specific mission problem that we started with for the first hardware product which is like a combination of hardware and software. It's not just hardware, but the mission problem was, hey, there's a specific type of ship that we are seeing the government struggle to detect in a useful way in a particular part of the world. And when we looked at that problem, we first approached it. We actually did first approach it from a software standpoint. We thought, okay, like, well, what types of data can we collect digitally? Like via creative means. Like, what can we get access to that provides us more information on this particular type of ship? And we actually got a decent part of the way down that problem set, and we did some really cool stuff. But at the end of the day, it wasn't completely solving the mission problem that they had, which is like, I want to know where the ship is and like what types of signals it's emitting. That's what caused us to say, okay, well, if we really want to solve this, then we have to build an RF sensor, because when we look around, we're seeing what the defense primes are putting out. It's things that cost like, literally 2 orders of magnitude of like the thing that we can build is like 100x cheaper. And yeah, the decision was not we're going to build hardware. The decision was, hey, there's like an important mission problem that we know is a top 3 problem for a certain number of groups in the government, and we're just going to do whatever it takes to solve that problem, which led us down like a hardware route.
How do you make that decision between pursuing kind of a bigger exquisite system versus a multitude of like smaller, attritable, less expensive nodes?
I think it all goes back to like, think about anytime you're doing product development in defense, probably anywhere, but like, especially, I only know defense. So anytime you're doing product development in defense, the most important thing is starting from the mission problem, not starting from like your perceived, like what the right, answer you think is. It's just what,
I'll interrupt you there for a second too. I had this question come up in an interview recently. And I think one maybe misconception about Vannevar and how we approach problems that I want to set the record straight.
Yeah.
I would love your take on it as well as our CEO.
Yeah.
But when we say that we're mission obsessed as a company, it's not necessarily that people care really deeply about national security. I think the thing that people miss sometimes is that, Vannevar, we're not an AI company, so we build AI products. It's more so that we're obsessed with the mission of deterring conflict in the Pacific, and working backwards from that mission, what products then do we need to build? And then if the answer is hardware, then the answer is hardware.
Yes.
Does that resonate?
I think it's exactly right. Yeah. Yeah. I think starting, like, how you get stuck building the wrong thing is actually presupposing what you think the right answer is. a common, like, for example, we thought the right answer was Arabic OCR in the beginning. So we spent an enormous amount of time trying to build like a perfect version of that, trying to sell it, didn't work. Instead of what we then started to do and started to realize was thinking about, okay, like what are the top 3 problems that we're seeing across these mission groups, and how do we sort of work back, like find what's common and then work backwards to building something that solves that problem. That's like the core. And I think good product development in defense is about doing that versus like, oh, I build X thing. I'm an AI, I build AI things or whatever. I think that's like a good way to not win.
Yeah. Well, I guess that said, are there any like fundamental differences in your opinion between hardware builders and software builders?
So developing hardware and software from like an engineering standpoint is completely different. I think for the main difference is your iteration speed is a lot slower on hardware. You have to be closer to being correct on the first bet that you make. Like your idea of what you think is right on a particular mission problem, you need to be more on target than in software. And the reason for that is like you might get 3 or 4 iterations of hardware in like a given 12-month period, whereas for software you get 3 or 4 iterations of software in like a couple hours, like or like a day or whatever, depending on what you're working on. So I think that you're able to take hundreds of more, maybe not hundreds, but like tens of more, like possibly hundreds of more shots on goal for the software side, where you're able to like iterate and learn. You don't get as many shots on goal from a hardware standpoint. So that is like the big fundamental difference between developing hardware and developing software. Failure mode on the hardware side comes when you fall into the same trap of like, I am presupposing the specifications on this hardware are the right specs. Like I'm building a UAV, it's going to have this range, it's going to be able to carry like this payload. And being really attached to those specifications versus being attached to the mission problem. I think I see a lot of companies build in that way. That can work if you're building like 10 different hardware products. You have more room to like be wrong a few times, but the main difference between hardware and software is just how many shots on goal you have. And you need to be closer to on target, I think, on hardware on your first couple go rounds than you do on software.
As the CEO of what was until recently a software-only company, how did you or have you been getting smarter on hardware?
I'm really relying, honestly, on like the team, like which is like Scott, and there's a few people, Scott, our CTO, and then a few people on the engineering and our product team, the mission strategy team, that are kind of getting in there and blazing the trail for us on like the Vannevar side for how to do this. So that is like a huge part of it. In terms of other things that I'm doing is just like talking to defense CEOs where I can. Like there's a few hardware CEOs that I talk to somewhat regularly, and that gives me a sense for how they think about the problem. And then I also pay attention to like what works for them from like a revenue standpoint. Like there's some hardware companies that I've seen, build a lot of products, and for me it's been interesting to see like which of those products actually achieve growth and why. And what I've seen so far is kind of what I just described, which is the products where you had somebody predetermine we're going to build X hardware thing because it has Y features seem to do a lot worse than like the situations where you're actually building from like a mission standpoint first and working backwards. There's like an additional challenge here on the defense side, which adds noise to this, which is like the program offices that write the biggest checks in defense actually they buy based on hardware specifications sometimes, like based on like a checklist of requirements. It's hard actually to tell from the outside, like, is this a product actually good and is going to work in the long term versus did this team just have like a really good BD strategy and like really nailed it from like a BD standpoint? So that kind of creates a little bit of learning noise for people on the outside or people that are new to this on like, okay, what is actually the right way to go about it? The thing that is fundamentally true in either hardware or software is like your BD people and your engineers and your product people need to especially for new products, they need to all be working together on like doing customer facing things, like going to business development meetings, going to user meetings. And that is like very much like the common thread for things that have been successful that I've seen in the hardware space have that component to them.
Are there any other aspects of the government customer that shape how you build a product? Like you mentioned the requirements piece, but is there anything else?
Physical access and testing is really important for hardware products. I don't know if it really shapes how you do for us, it actually does shape how we do product development. So what we end up doing is like on the software side, again, you can release so quickly that you're going to iterate like much more quickly anyway. But what we did in the early days of Vannevar on the software side is we would pick like DoD operational dates, like things that our customers or our users were like doing from a mission standpoint that was like a live operation or like a live exercise on a particular date. Let's say it's like April 30th or whatever. And we would use that date, and then we would set that as like a deadline for us internally to get our stuff together, and really focus our product development effort, because like we're going to be shipping something on that date, whether we're ready or not. And that method is critical on the hardware side too, partly because the development speeds are like, it's so much longer to iterate. So we do the same thing of, okay, we're going to deploy our RF sensing kit overseas in these countries on this date, and that drives a lot of our like product and engineering effort and decision making. And I think that real world testing, setting those up and like doing it from a logistics standpoint for hardware is like hard, and it's like whole functions that are dedicated to doing that. But that concept of like use hard operational test states to drive product development is like very key, and possibly more key from like a hardware standpoint, to like force yourself to have like real world at bets on certain things.
Maybe a rudimentary question. Yeah. What if the hardware is not ready by that date? Like how does it? Yeah.
You're still, I mean, our take, so like the first time we shipped our RF sensor overseas, we did it kind of like in concert with one customer group, but we also sent some engineers to just deploy it on a beach in the country we were operating in by ourselves. And what we found when we did that was like, turns out, like it's really hot when we were deployed. And so you have like more heating issues that you have to deal with. You have like power, like the battery that we tried to, ship in country was, stopped at customs or something. So we then have to find like an in-country local battery source. And like, oh, we didn't know we had to do that. So you're forcing yourself to go through the exact same deployment mechanisms that you'd have to with a customer is like really important. But when we kind of deployed, let's say, I can't remember exactly what it was. Let's say we deployed like 6 kits out, in that one deployment, and like 4 of them failed. We can't get them up and running, but 2 of them work. And what we found was actually we had a sensor overseas that was running and worked that we actually kind of on the Vannevar side knew was there, but we weren't tracking like the usage of what was going on super closely. And it turned out that the government actually, independent of us, took that sensor, did some really cool things with it, and then just told us like after they got back from that deployment, by the way, we did all these things with your sensor. Like, oh, that's great. So I think it doesn't matter if you think you're ready. It's just like you have to make yourself deployed, because that's the only way you're going to figure out what's broken. And sometimes you'll get lucky. Like we got maybe a little bit lucky that we had a sensor that worked and actually was like put to good use out there. But you have to, forcing yourself to deploy overseas, even if you're not ready, is good. It's a good habit.
You talked a little bit initially about building a systems integrator and becoming a systems integrator. And in defense, software is often layered onto hardware. And defense still is a pretty hardware-centric world. How do you build effective systems across those 2 domains?
I believe that for new products, for us at least so far, the best results for 0 to 1 always come when you have like a very, very small engineering and mission team working together. And when I say very small, I mean like less than 8 people. I mean like a very small team. And so for us, for that RF sensing product, the engineering team is not 3 anymore, but it's not 15. It's still like it's still small enough that there are software engineers, there's kind of like RF signals experts, and there's kind of like hardware engineers, and that whole team is like sub 15 people right now. I think it's really hard to build like totally new 0 to 1 products once the team gets big and like too big that not everybody knows each other. So we've had the benefit of like for the 0 to 1 phase of just trying to keep the team really small. And that allows you to like, actually, you can, when everybody's on the same team, has the same incentives, you can build things really quickly. It gets way more complicated once you have to split, teams and like, oh, there's a separate software team, there's a separate hardware team, and there's different managers and they have different incentives and all that kind of stuff. That's more of a, how do you deal with that when you scale versus like, how do you figure out the 0 to 1 product thing to build? Again, I'm not an expert in this domain, but that's kind of what we're seeing so far for this.
Yeah. Recognizing that we're still pretty early in this hardware effort. Have you thought about how, and kind of how you mentioned, like having this tiger team of people working on our nascent hardware product, have you thought about the differences between actually scaling structurally a hardware company versus a software company? And I'm sure it is also colored by the fact that we're 200 people now and things are, sometimes go sideways anyway. But like, have you thought about that distinction?
Yeah, I think Some of the principles I think are all still the same of like small teams focused on building, from like a mission first standpoint, like focus on like live testing and deployment with people in the field. Those principles are all the same. I think the difference is like when you're building hardware, you have to physically manufacture things in a place. And right now that's like we have like a very small office where that's where we do that. But I think, as you kind of scale that manufacturing out, that's like becomes like a whole operational challenge, and you need people in person, and you need like the right skills in person, and you need like a regular cadence of when to do in-person testing for different types of like things that you're preparing for. The hardest part, I think, is like actually figuring out what the right problem to bet on is, and then building the 0 to 1 like initial concept that actually has like what we call product mission fit. I think scaling operations is like also difficult, but it's in the realm of like a solvable problem. You're not having to invent. Like the inventing part, I think, is the hardest part. And I think that our sort of approach on the, how have we done this for the last, 6-ish years, I think is going to work too. But like, we'll see.
So with those teams and the hardware component and the software component, how do you think about aligning incentives when they operate on such different cadences?
Yeah, so I think tying to operational like use is really important. This is what I mentioned, like those hard like dates if we were going to play this thing out with users like at this particular time. For us, that's been a great. I've seen like a lot of that's worked really well internally for us. Like I'll give you an example. We deployed overseas somewhere in Europe, and there's like a partner, DoD group, and a partner that wanted to deploy this thing to track a very particular type of vessel, basically. That caused the hardware team to then think, okay, well, man, we have to have everything set up to be able to collect the type of signal that they want. But that also caused the software team to then be thinking about, okay, how do we like ingest the data that the kit is produced? Obviously, we're like thinking about this anyway, and we've been working together from like a product development standpoint to build the thing. But it's a forcing function of, right, we're going to deploy this overseas with like a US partner that's like using a little bit of their capital to get us this type of access to support like an important mission. So like we are going to make this work. And that hard date, like and having everybody singularly focused on that mission is what, causes people to work together. I think for us it's easy because it's, we think about building in small teams. It gets a lot harder, I think, when you're talking about, like 100, 200, 500 person engineering team that's working on a hardware product. But that's not we haven't had to deal with that yet. Yeah.
I'll ask you something, maybe a hot topic.
Okay.
Vannevar is a remote first company, which I think is the draw for a lot of our talent. And, people can live anywhere, work from anywhere. I think that's, a huge reason why a lot of people join, that tied with the mission. How do you think about building hardware with that setup?
Yeah, you have to be in person. Like you need some portion of the hardware team to be in person working together. Just it's like not possible to do testing and assembly and all these things remotely. Doesn't mean that the whole team needs to be there all the time. It does mean that people need to be kind of flying to the same place to do something at some regular interval. And so I think as we've scaled, and by the way, I think that's true for like new product development for software too. Like having periods of time where you somewhat regularly get in person and work on a thing is really important. The way that we have typically approached this is like working on military bases with users. From a software standpoint, that is like our forcing function for getting people together on like a regular interval. Is like I think that's what we've been doing for hardware too. But we also have 2 offices now that are kind of like 2 dedicated hardware spaces.
And where are they?
Seattle and New York City.
Yeah.
Moving to Seattle, I think, longer term. But hiring people that are, in local to that area and giving people also like relocation bonuses for people that want to move out there is kind of how we're thinking about it. But yeah, you definitely need people in person to build things for sure. Yeah. But you don't need the whole team, and you can solve it with like being aggressive in how you set up like team travel and offsites and customer visits, that sort of thing.
What do you think traditional defense primes can learn from startups or just tech native software companies as they're building hardware or combined systems?
Yeah, I think the primes are really good at building very low fail rate, super exquisite assets. I think the key thing for defense primes is like velocity is the problem. Just kind of like speed of iteration and kind of getting to like a product with like in a reason with a reasonable cost is like a thing. Startups and like us have a lot to learn actually from defense primes. Specifically, I think for us, like we spent a lot of time focusing on like the mission problem and the user, and it took us probably 3 years, I would say, before we started to focus on like the program office and requirements and like program managers and trying to map out how that all works. And then also government relations and kind of like how does Congress sort of like relate to all this, all that sort of, those are all things that the defense primes are world class in, like absolutely world class in like all of those things. And it's something that we are very much, we have to learn a lot from them. So I think a lot of the new defense companies, us included, benefit greatly from sort of understanding how all that works. And yeah, I think on the defense prime standpoint, it's really a structural issue, I think, with them where, like a lot of these programs are awarded on a cost plus basis. And so what I've seen for software programs that are cost plus, it incentivizes like delay, like just sort of delayed release and like an exaggeration of the number of engineers that are required to build a thing and just sort of like compounding costs to eke out whatever like the 7% margin like that. In order for that 7% margin to be meaningful, like the cost basis on these programs needs to be really large. And I've seen that as like a complete like failure mode for software programs. But that's, cost plus is like how all of the most of the major acquisition programs on the hardware side are sort of run. And it just structurally incentivizes, like, in my opinion, like kind of bad behavior. There are types of systems where, maybe the defense prime can't front all the R&D money to get the thing off the ground. There's like very valid, like big satellite thing, or you're just not going to have like a new like unmanned surface vessel, program be successful run within a defense prime on like a cost plus basis. Like I would say the odds of that happening are like round to zero. I don't know what they are, but so yeah, it's not high. So I think there's a lot of structural factors that are working against the primes that it's not really in their business incentives right now to figure out. But that is sort of, that's the key barrier for them in terms of product iteration from like a hardware standpoint.
Yeah. People say that hardware is hard, and I'm sure you tempered your expectations before, embarking on this process. That said, is there anything that has like really been unexpected for you?
Yeah, I mean, I think the fundamental belief that we had when we started Vannevar is still largely correct, which is like you have this, again, massive market. It's like 400 billion in procurement spend for defense that goes to defense companies. And you largely have very old incumbents that haven't needed to think try new things and have sort of been structurally incentivized actually against like being innovative and trying new things. And so those are the dynamics of the market. And that applies to software as much as it does to hardware, where I think, yeah, what we're saying, just using like, again, the RF sensing space as an example, we are right. It's not even a competition because they're such wildly different systems, but you have like the closest thing that we see from a competitive standpoint is like a $400,000 like big kit that like when we deployed forward with some of the DoD groups we were working with, they couldn't even set it up because it was so complicated. So it didn't work. And the thing we're building is like we can build for 5,000 or less, per unit right now. And that's like, that's 2 orders of magnitude different. And it's just because we are using things that are not 20 years old, I guess. Like we're just kind of like looking at whatever like the most recent technology is, both from a software standpoint and from a hardware standpoint. And we just have the ability to invest our own R&D to just try a bunch of things out. And, that's sort of, I think, what is lacking, I guess, a little bit on the defense prime side.
When it comes to building hardware and deciding as a company to do that, how did you think about, or how are you thinking about the build versus buy equation?
Partnerships are really key. They're key for software too, but they're I think probably more key for hardware. And so for all the component, like when we're kind of building this RF kit, we're constantly trying different components, trying different sub suppliers and swapping them out. And that is, really key. I think like partnerships and having good relationships with for whatever you're building, the subsystems that like are required to build the thing is like very, very important. So I think We are finding that, I mean, just for this RF sensor, we're finding that a lot of the sub components, we can find best in class systems and kind of combine them together to get something good. But we're finding that on the software and signal processing side specifically, that's mostly things that we have to build on our own, with some exceptions of partnerships that we have there. But I would say for hardware, it's like especially important to have good partner relations.